everyone, and thank you for joining us in our first webinar of 2014. We are excited that over 250 people signed up for introducing 4D v14 today. The hosts for today's webinar are Brian Young, 4D Technical Marketing Manager, and myself, Aaron Mueller, 4D Field and Partner Marketing Manager. Brian?
Thank you, Aaron. After this quick introduction, we're going to go right into our presentation for the day. The topics we are covering include a new language type and some very important improvements to external access and mirroring. Afterwards, we have a couple quick announcements before taking your questions for the remainder of our hour together.
I would like to introduce our speaker for today's webinar, Josh Fletcher. Josh has been with 4D for over 8 years and is our 4D Technical Account Manager. Josh, take it away.
Thank you, Aaron. Thank you, Brian. So we're going to actually take this off speakerphone so you guys will get better audio during the presentation. So give us just a minute to switch over and we'll be back with you.
Okay, so let's get started. So we're going to be doing a pair of webinars introducing v14. In part one, I really want to focus on the core of 4D. So 4D v14, I mean, it's a fairly major release for sure. And hopefully you're going to see some really exciting features that make you want to try this new version. I said I want to focus on the core. So there's 3 areas, I think, of the v14 release that kind of make up the foundation of the changes that we have made. Objects, external access, and mirroring. And so those are the 3 topics that I'm going to talk about today. So let's get started with objects. So we have objects in 4D v14. They represent a new type for 4D. I think that in order to kind of really convey the importance of this and kind of get an idea of what's happening, it's good to sort of explore what do we mean by objects in kind of an abstract fashion. So what is an object? And really the question that I'm asking here is, what do I want an object to be in 4D? I like to define this using an analogy to start with because I think it makes sense for 4D developers, this analogy. So if we think about records, a record is a pretty good representation of what I mean by object. It's a collection of different variables. And when we have some values in a record, it's a collection of different values that is unique. It's uniquely identified, and it's all bound together. With the database engine, though, we can do some interesting things like, let's say I have a company record, but the company record happens to have multiple addresses, and maybe this is some financial software, so they also manage multiple funds. So I can actually create some pretty complex structures using the database engine to represent what we might consider an object, the company being an object. And of course, the way you keep all of this bound together using the database engine is you use relations so that you can keep everything organized. So I think that analogy leads us to, well, wouldn't it be nice to have some similar ability, but using the programming language instead of the database engine? So let's look at a programming example. Here's 3 interprocess variables: first name, last name, and home folder. And the fundamental question here is, what is the relationship between these 3 variables? What is it that binds them together? Now these, based on the names, we might consider these to be preferences for a user. But the fact is, other than the relationship that I create, there's nothing that binds these variables together. The only thing that maybe binds them together is their scope. They all have the same scope. But otherwise, it's completely up to me as the developer to create a relationship. Now, good developers, good 4D developers do that usually by a common naming convention. So in this case, all 3 of these variables have the same prefix. But even something like that, a simple solution like that, can get pretty hairy as you start to add more and more variables into the mix. And it gets difficult to manage. And to be honest, this is computer software. I don't want to manage this myself. I want the software to do it for me. So that's one of the things I think that objects looks to address, is to bring this encapsulation into the 4D programming language. Let me go back to the simpler example with just 3 values. So I'd like to be able to take those 3 things, group them together, and have a reference to those things and keep them separate. So I get the Josh object effectively, with the first name, last name, and home folder being properties of that object. So it's almost like creating a template. So now I've got this template that's a sort of a user template, and it's got the first name, it's got the last name, and so on, and I can create copies of this, or objects, one Josh object, one Laurent object. Now there's something very important at this stage in our description. If I change the first name of the Josh object, nothing happens to the Laurent object. In fact, nothing happens to any other object in my database. That's what I want. I want them to be completely unique. So that's very important. Now I mentioned the word templating, but the fact is I don't really want to be bound to a specific template either. I want to be able to maybe add another field and create an object with 4 properties instead of 3 properties. I want that kind of flexibility. I also don't want to be limited to just scalar types, so text and booleans and numbers, but maybe I want to be able to stick an array inside an object, or even another object inside an object. So this last example that you see here, the object with the reference deep thought, the property answer is actually another object, and that's denoted by the curly braces. And I'll explain why I'm using curly braces here in a few minutes. But that sort of, I think, gives you an idea of what do I want objects to be? What is this feature we're offering in v14? What does it do? So to sum that part up, an object should be a collection of values that are bound together. There should be no predefined schema. I should be able to alter the structure of the object any way I want. Everything is bound together, and that really leads to the very important point that each object is completely unique. That's what I want them to be. Okay. So what are objects in 4D? So as I said in the beginning, it's a new type. So it joins our list of types. It's called C_object, or that's the typing definition anyway. That's how you declare an object. Being that it is a built-in native 4D object, of course, there is a whole new theme of commands to deal with objects. Sorry, I skipped one part here. Give you an example. You might want to see how they work. So here we're creating a C object, an inner process C object, and setting some values. So there's a command obset that allows me to assign values to an object. In this case, I've got first name, I've got last name, I've got an array, which is the Fibonacci sequence of numbers, and a Boolean and another object. Now, I think one way you can think of this is kind of like an array, where with an array, you use an index to find a location. With an object, you use a name, a key, to find a location. So what we're talking about is key value pairs. The first name is a key, Laurent is a value. Last name is a key, Ribardier is a value, and so on and so forth. So that's the way you would, a simple example of how you would create an object. And of course, getting back to what I was saying a moment ago, being a native type in 4D, we have a suite of commands to deal with objects, to get values, to set values, to test if things are empty and that kind of thing. I'm not going to go through each one of those commands. There's one particular point that I want to focus on. The objects are very easy to turn into text or to take some text and turn it into an object using these 2 commands that you see down here at the bottom, JSON parse and JSON stringify. And that's kind of a jumping off point to explain what's going on under the hood. Why do those 2 commands have JSON in the name? What is JSON? So JSON is an acronym. It stands for JavaScript Object Notation. And it started life in JavaScript. But the interesting thing about JSON is it's actually been kind of extended to become a de facto standard in the industry for data transport, but using text. So even though it stands for JavaScript Object Notation, you can kind of just call it an object notation because the fact is it's supported in so many different environments. It's very popular and it's very easy to use. So like a good developer, even our 4D engineers are like good developers, and rather than reinvent the wheel, we stole something, we discovered a solution that had already been created to solve this problem. So the problem is data interchange over HTTP. That's what JSON was created for. Now you might say, well, that's what XML is for, and that's true. JSON is similar to XML in the task that it's handling, but it's much simpler in terms of the code and the overhead. So in that sense, it's much easier to work with. So just a basic example of what some JSON looks like. And this is where the curly braces come from that I was talking about earlier. So in JSON, to create an object, you have an opening curly brace, and then your properties and values are just a label with a colon and then the value following afterwards. And it supports strings, it supports arrays, it supports booleans, and it supports numbers, and of course other objects within objects. So under the hood, CObject is actually using JSON. And this very much comes out of the efforts that we've put into Wakanda. The fact is the 40 engine, the 40 core, which is shared between Wakanda and 40, has had support for JSON for quite some time. And so we're sort of exposing it in 40 v14 as its new type. Okay, so I'm going to go through some examples of things that you might use objects for. The first example has to do with parameters. Now, as you know, the way you pass parameters in 4D, you use $1, $2, $3. But in this particular example here, I have an optional parameter. And you know, as 40 developers, an optional parameter just means it comes at the end of the list. You can not pass it if you don't want to. But the important thing is, since my third parameter here is optional, if I want to add a fourth parameter and have it be required, I can't put it, in this case, as $4. It doesn't work. With 40, the optional parameters always have to come at the end. So to really do what I've got here on the screen as an example, I need to reorder the parameters. I need to have the optional parameter move down into $4 and the required parameter be $3. Of course, modify my code to check for the new parameter and that kind of a thing. What if we instead use an object for this kind of issue? So now what happens is I only pass one parameter. Sorry, I skipped probably the most important part. Let me go back one. Once I've added that new parameter, I have a problem, which is I have to go through every place in the database where I called this method and make sure I take into account that new parameter. I have to refactor those calls. It can be a bit tedious. Okay. So if we use an object, we pass one parameter to the method always. That never changes. So there's no refactoring in that sense of the other methods in the database. I can add and remove parameters as needed from this object. So right now I've got 4 parameters being passed into this method. I can remove, let's say, the second parameter. That's no problem. 40 is not going to complain at runtime. Of course, my code has to be adjusted that's accessing the parameters. If I take something away and I'm trying to read it, it's not there anymore. I'm going to get an error. But it brings this flexibility to be able to add and remove things. There's another interesting aspect, which is, what about accessing the parameters in a different order? So in this example here, I'm accessing the second parameter first and the first parameter second. So that's fine. With an object, I can access the contents in any order I want. Now, parameter passing, that's kind of interesting. I think the best place to use this, at least that I've found so far, is to encapsulate form variables, form values. When you want to take a bunch of values from a form and hand them off to a method, it's very convenient to pack all of those values into an object and then hand that object off to a method instead of either constantly modifying the parameter list or directly accessing the process variables. So it's kind of nice to be able to encapsulate it that way. But I think what's even more interesting is, what if we return an object now instead of a Boolean or long int or whatever? Well, what this actually means is I can return more than one value from a 4D method. It's only one value true, but I can pack anything I want into that object. So in this case, there's just some parameter checking code that checks to see if the first parameter was passed and the second parameter was passed. But the cool thing about it is I can return a unique error message depending on which one you forgot to pass. I can stuff that into an object. I can return that object. So that's pretty cool. That's nice to have. Let's look at another example. This is a very common design pattern in 4D, which is to take variables, to take values, and stuff them into a blob to be able to transport them around or whatever, to have a convenient way to save them, and then be able to access them later. So here I've got a blob that contains a name, the gender, the birth date, and an email address. Let's compare this to using an object. Now the creation code looks about the same. I have 4 variable to blob calls for the blob version. For CObject, I have 4 OBSet calls. That doesn't really look that much different. Where it gets interesting is when you want to access values. So let's say I want to create a method to only return the birth date. I can certainly do that with a blob, but with blob to variable and variable to blob, I have to access everything that's in that blob in order. So in order to get the birth date, I actually have to remove the name and the gender, and then I finally get the birth date that I can return. With an object, you just access it directly. If you know what the property name is, you just call obget. Here's the property name, here's the value. So you don't have to know the structure of the blob. You don't have to parse through the blob to get that value that you want. That leads me to the final point, which kind of has to do with introspection, which is, I don't know if it's a word commonly used in a 4D context. But introspection basically means being able to self-analyze in a programming context. And the interesting thing about CObject is there's a command like obgetPropertyNames that will actually give you a list of all the properties contained in that object. And you can iterate over that list. You can check to see if it's null, if it's empty, what the type is. You can do all this introspection that you can't do really with a blob. Unless you've really dug into the internals of 4D and you know what the format of everything is. Sure, you can dig through blobs, but I think for the general 4D developer, that's not really realistic. So blobs bring this, CObjects bring this level of flexibility that we didn't have with blobs for this kind of a technique. That's pretty nice too. All right, I'm going to look at one more example. I'm going to switch to a 4D database that I have running. So this is 4D v14. Now, the first thing, as I click this query button, there is a new query editor in 4D v14. It's got a modernized look and feel, but it does what you expect in the sense that it allows you to query and get data. So I'll go ahead and run this query here. It didn't return any data because it's not a good query. But what I want to point out in the context of talking about CObject is there's a feature in this new query editor. Up here, this button that says Recent Queries. It actually maintains a query history for you. And if you switch to a previously saved query, it fills in the table, the operator, and the values. So I'm going to choose one here. And so we're querying the state, we're querying a Boolean field, and we're also querying the date invested, and I'm going to say in the last quarter, and I'm going to run that query. And it goes off and it finds some data. Okay, so why am I talking about this in the context of CObject? Well, what is a query? I think it's a good question right here. A query is any number of tables, any number of fields, any number of operators, any number of values. It's a totally schemaless collection of stuff, which, when you think about it, is the definition that I just gave of objects. So the query editor is using CObject. And behind the scenes, as I mentioned, that's JSON. So I'm going to go ahead and export this query out to disk. And I'll put it on my desktop so it's easier to find. And I'll go ahead and open this up in a text editor. So there's my query that I just had in the editor, but represented in JSON format. Now, one thing that's interesting to think about here, aside from the fact that it's very convenient to use CObject for this kind of a feature, JSON is meant to be a human readable format. It's text. It's a text-based format. So the fact is, you could actually edit this query file, import it back into 4D, and run the query. More to the point, you could edit a query file, send it to a user, ask them to import it, and run the query. You can do all of that completely outside of a 4D context because it's just a plain text format. That's pretty nice. So let me put this away for now. close my query editor. Okay, I'll switch back over to the slides here. Okay. Now, what I want to point out is we just looked at 3 different examples of CObject: parameter passing and return values, blob versus CObject, and the new query editor in 4D v14. All 3 of those examples are using CObject, but basically to solve different problems. And that's really something very cool about CObject as a feature. It's the kind of thing that you kind of didn't know that you missed it, but once you have it as a feature, it does a lot of it solves a really diverse set of problems. So it becomes a ubiquitous feature. As we worked with v14 and worked on the webinar content and things like that, we started finding all different kinds of problems we could solve using objects. And so I want to reinforce that to say that not only can you use CObject all over the place, but we use CObject all over the place within 4D. The new query editor is an example of that you already just saw. There's a key value pair engine that we use internally that's now using CObject. There's some features that I'm actually going to talk about in the next webinar, the real-time monitor and form geometry in the web area, that are all using CObject. And of course, the big one, the doozy, 4D Mobile, which is the communication between 4D and Wakanda, relies heavily on this native JSON support. So we're using it all over the place in 4D as well. And that really leads me to the final point. So I'll wrap up CObject here. It's a new type in 4D, which is very powerful. That doesn't happen all the time. It's very flexible. We've seen how it can solve different problems. It's very convenient to use because it is a native integrated 4D type. You get the kind of support that you expect using something within 4D as opposed to using like an external tool. Okay. So this leads me to something that we just wanted to make sure and share. The 4D language has gone through a rough couple of years. There was talk of replacing it with an object-oriented language, or replacing it with JavaScript or ECMAScript, things like that. And what we've come to realize is that that is not the right solution. CObject is a reflection of the fact that, no, you know what? We've decided to commit to the 4D language. We're going to stick with the 4D language. The 4D language is very good at what it does. And what you do is you build business applications. And the 4D language is very good at doing that. And so we're going to stick with it. We're going to update it. We're going to modernize it. And CObject is a reflection of that commitment. There's also some other types in v14 that you've been waiting for, like array blob and array time and so on. So I just wanted to make sure and point out that this is sort of a reflection of our recommitment to 4D, to keep it modern, to keep it up to date. And you'll continue to see that kind of investment as we move forward. Okay. So enough harping on CObject. The next topic for today's webinar is external access. Now, what do I mean by external access? There's a lot of different ways to access 4D data from a non-4D context, whether it's HTTP, the web server, or SOAP, the internet commands plugin, things like that. But really, what I'm talking about here is ODBC. And the reason why I'm talking about ODBC is, which is also known as Open Database Connectivity, ODBC enjoys incredible cross-platform support and cross-application support. It's a very popular way to access data. And so back in V11, we updated our ODBC driver to give it direct access to our native SQL server. And it continues to be the way, if you're going to have an external tool accessing 4D, it can be one of the best ways to do it. But with any external access, there's a question of security. What kind of security layer is there, and how secure is the access to my data? So what we have today, up until v14, is we have users. Users belong to groups. Groups are a part of schemas. And all of these things combine together to control access to tables. Read and write access to the tables in the database. The question is that enough? And it's kind of a rhetorical question. Of course, that's not enough. For true external access, if the only thing I can control is tables, it's not really going to cover everything I need. Let's look at why that's the case. So I'm going to define this answer. Is that enough? I'm going to answer this question by looking at a task. I want to provide a list of contacts for companies to a user that's using Excel. Okay. So here's my typical 4D database. I've got a company table, I've got a contacts table, and I'm going to give, this person access to these two tables. Okay, problem number one. This is not a typical 4D database. You know that. This is a typical 4D database. If I provide a user with access to these two tables, and they do select star, they're going to get access to a whole bunch of fields that they may have no business looking at. I could have sensitive information in those fields that I shouldn't be exposing. So that's one problem. Another aspect I think that is a problem is the Excel user is probably not going to want to have hundreds and hundreds of fields in their spreadsheet that they have to deal with cleaning up. So there's an aspect of convenience also that can be an issue. Okay, but of course they don't have to do select star. They could build a query and get the pieces that they want. So the company name, the first name, the last name, the email address. But I don't want an external user to know the structure of my database any more than I want them to know the data. So this query that I have here implies several different things. It implies they know which fields they want. It implies that they know how the tables are related, so they know how to create the join. That's a bunch of information that I don't necessarily want to give away outside my company. So how do we solve this? So in 4D v14, we have support for SQL views. And that's how we're going to solve some of these problems. A view is very easy to create, first of all. So I'll just give you a basic example of the syntax here. So the views are created with SQL. Just to be clear, you got to do a SQL statement. So begin SQL. It's made up of two pieces. The first part is a view definition. And this is completely virtual. It doesn't have to correspond to anything in your database. So you create the view, you give it a name, and you give it a list of column names. And those can be anything you want. The second part is a query, a select statement. And that's how you tell 4D which data to put in this view. And that, of course, that corresponds to your database, but the user isn't going to know that. So keeping this task in mind, contacts for companies to an Excel user, let's actually look at it. Let's see how it works. So I've still got my 4D database running. I'm going to switch to Excel. I'm going to go data, get external data, new database query. I've already got the driver configured, so I'm going to go ahead and use that existing configuration. Type in my super secret credentials. And this opens up Microsoft's query editor. I'm going to switch to the SQL view so we can write some raw SQL. Now I'm going to cheat a little bit. I'm going to go to my text editor and copy that SQL statement and paste it into Excel. Oops, I'm going to hide the text editor actually. Okay, there we go. So I'll paste it in here and I'll run it. Now, of course that works. If I expose access to the tables, the user can run this query and they can get the data. That's not what we want, but just to show you, it does work. There it is. Okay, so that's the data coming from the 4D database. Now, instead of giving direct access to the table, let's use a view. So I'll switch back to 4D. And I've got a method here called create SQL view. So here's the view definition. So create or replace view, contacts for Cosmo, company, first name, last name, and email. Now I'm calling this contacts for Cosmo. We had the summit in Las Vegas this year, and we stayed at the Cosmopolitan Hotel. So the supposition is maybe I'm trying to create a list of contacts for the Cosmopolitan Hotel. So I will paste in that query. So we're selecting from the company table and also the contact table, and we're getting data and we're sticking it in this view. All right, so I save this method, I run this method, and I wait. No, I don't wait. I said views are very easy to create. That's literally it. Put the definition in a method, run the method. The view now exists. There's no pre-filling data or querying or sequential searching or anything like that. It's just a definition. It's just an abstraction. And so now what I've got is a view named Contacts for Cosmo. Let's switch over to the Microsoft Query Editor and use it. So instead of all this gibberish, select star from Contacts for Cosmo. I get the exact same set of data that I was getting before, but now as the Excel user, I don't know anything about this database. I don't know the tables, I don't know the fields, I don't know the relations. All I know is here's the data that I asked for. So what have we added? We had table level control already. Now what I have is column level control. I can control which columns the user has access to. Now let's add another aspect. So right now I've got a list of all the contacts in the database, but the Cosmopolitan Hotel is actually in Nevada. Maybe I only want to give them the contacts in Nevada. So I just add another query constraint. Company dot state like NV. Save, run, go back to the Microsoft Query Editor. Not going to touch the SQL. And now I'm limited to just the contacts in Nevada. But that change was completely transparent to the Excel user. They have no idea that I changed something. So now what I have is row level control. Not only can I control the table they have access to, I can control the columns they have access to. I can also control the rows they have access to. And views from the external user's perspective are just tables. So I can, instead of selecting star, I can select company only. And get the one row, the one column. It's to the external user, it's completely transparent. It just looks like a table. And so they can use it that way. All right. Let's go ahead and exit out of Excel here. Close my 4D method. All right, let's switch back to slides. So I think the thing about SQL views is if you understand why we added this feature, you really see the power of it. The fact of the matter is we added SQL views to v14 primarily for compliance. Organizational compliance regulations, things like HIPAA, which covers medical records, you have to have column level control and row level control to be HIPAA compliant, period. It's not optional. Excuse me. So that's the main reason why we added SQL views. Another advantage of having views support is for tools like Crystal Reports and Microsoft Dynamics GP, which used to be called Great Plains. So it really expands 4D's ability to offer external access to these kinds of tools. And there's an interesting aspect to this, which is you can use views within 4D. Once you create them, you can query them just like regular old SQL tables and get data. And so it opens this interesting doorway of building denormalized access to the data to build user-oriented features where you might have end users that are not database developers. They don't understand relations. They don't understand tables. So you can give them a flat interface into the data. That can be very nice too. Brings a layer of convenience for sure. All right. Last topic for today. Call it full-time mirroring. I think in order to understand what I mean by full-time mirroring, we got to talk about mirroring in general. Okay. So what is mirroring in 4D? In some ways it's complex, in some ways it's actually really simple. Mirroring is based around two commands, the new log file command and the integrate log file command. You use the new log file command on the production machine to create log segments, and you integrate those segments on the mirror machine. And that's how you keep the mirror machine up to date. I'll walk through a demonstration of what I mean here, just so everybody's on the same footing. By the way, if I use the word log file or I use the word journal file, I'm talking about the same thing. We use both terms within 4D. So here's how mirroring works in v13. You have a production server and you have a mirror server, number one. Number two, you have to have the journal file enabled on the production server, also called the log file. So how do we do mirroring? Well, the mirror is read-only, first of all. you call the new log file command on the production server. That causes 4D to create a new log file. It takes the old log file, it gives it the 4BL extension, and this is something that we commonly refer to as a log segment. So you create the new log file, and then using some technology, it doesn't really matter what the technology is, that's up to you. You copy that segment over to the mirror machine, and then you call the integrate log file command to integrate those changes. So what you're left with is the mirror has logical parity with the production machine. It is as up to date as the most recent journal file that was integrated. And that's pretty good. Let's look at why that's good. So let's say the production machine fails. It's dead. I need to use the mirror for recovery. How do I do a recovery? Well, first of all, you have to take the most recent journal segment from the production machine and integrate those changes into the mirror using integrate log file. And now what I have is a fully up-to-date copy of the database, ready to go into production. So I put it in production, and I get rid of the old production machine, and I'm recovered, I'm ready to go. That's very cool. Okay, so what's the problem? What are we addressing in v14? The problem is my new production machine doesn't have a journal file. In v13 and in previous versions, the mirror can't have its own journal. So when we switch to the mirror, we have an integrity problem. We're not being protected by 4D's excellent journaling feature. So that's not good. Okay, let's look at v14. Same initial configuration, production mirror with a journal file on the production machine. The first major complicated change, it's not really complicated at all. The mirror has a journal, period. So we solved that first problem in v14 by allowing you to turn the journal on in the mirror. Now the mirror is being protected by 4D's journaling system. Let's walk through the rest of the scenario. So we create a new log file on the production server. We send it over to the mirror server. Now one thing that's different in v14 in this scenario is instead of integrate log file, I have a new command called integrate mirror log file. Because the mirror has its own journal, I have to differentiate the fact that I'm grabbing a log file from the production machine and I'm going to integrate those changes. So we integrate the changes. Now all of the changes that were just integrated are being journaled into the mirror's journal file. And that's what makes it very good. Now the mirror itself is recoverable. But let's keep going through the scenario. So the production server goes down. I bring the last segment over. I integrate the changes. I turn my mirror into production, get rid of that production hardware that was dead. But the difference today, the difference in v14 is my mirror is protected by 4D's journal file. That's very, very good. Really, really good. Big improvement. It gets better than that though. Because my new production machine, which before was a mirror, is being journaled, I can bring in another mirror. Why not? Start segmenting my new production machine, sending those journal segments over to my new mirror, integrate the changes, and now, at all times, I can have a production machine and a mirror machine. So in the beginning when I said full-time mirroring, that's what I mean by full-time mirroring. We can always have production, we can always have a mirror. And in fact, with this design where I showed you originally a production, a mirror, and then another mirror, I could actually have all three of those running at the same time so that in any instance there's at least two. If I switch over to a no production machine, I've already got a mirror machine ready to go, and I can round robin in that way. So that's what we mean by full-time mirroring. Now, whether or not you want to use mirroring, there's an important point here, which is we added this full-time mirroring so that when a customer says, is 4D reliable? You say, of course 4D is reliable. We have backup integrated, we have journaling integrated, we have mirroring integrated, and we even have full-time mirroring integrated if you want to do that. So whether or not you choose to use mirroring, and I highly recommend you do for some of you, especially some of you with large systems or distributed systems and things like that. But even if you don't want to use it, the fact that we have this now I think is very good leverage for your customers. Now in solving this issue with mirroring, we actually took the opportunity to look at journaling in general. And in what ways could we improve journaling in 4D? And there were 3 goals in mind with this task: to improve stability, to improve reliability, and to decrease the complexity of dealing with the journal. The flexibility that you just saw with being able to integrate mirror segments but also maintain your own journal, that's one of the aspects. I want to talk about another aspect that I think helps decrease the complexity. It's a feature that I call selective journaling. I don't know if you'll find that actually in the documentation, but I call it makes sense to me, so that's what I've been calling it. But I'll show you what it is. So you've got tables in your database, in this case the company table. The company table is certainly important to me. I want to make sure that's being journaled when I'm making changes to that table. There's a new preference in the table inspector, include in log file. You can turn that preference on, and those changes will be journaled. On the other hand, you might have tables in your database that are not important, like an error log table that contains error messages, and you don't really want to replicate that to a mirror. Well, go in and turn include in log file off, and that will not be journaled. And this gives you the advantage of removing unnecessary entries from the journal file. It makes the journal files smaller relatively over time. They'll have less information in them. It'll perform better. I mean, no matter what, when you're writing to the journal file, it does take some time. Not much, but it takes some time. So the fewer writes you make to the journal file, the better. So that's the kind of decrease in complexity, I think, and increase in stability that we're offering with the journaling changes. Now, the modifications to journaling they're kind of deep within 4D. And so if you're interested in kind of the deep details of why we made this change, or if you want to be aware of some of the issues that this might solve, I'm going to recommend that you go watch a video from Laurent Ribaudier, who is our CTO and founder and president. He gave a presentation about the new journal system, and we recorded it and published a video on YouTube. So if you're interested in those details, go check it out. We're going to put this link up at the end of the webinar also, so if you can't get it down right now, don't worry about it. We'll show it to you later. But you can check that out. All right. So today I talked about the foundation of 4D v14. With CObject, we got a native new type for 4D. It's flexible, it's convenient, it can be used to solve a whole bunch of different problems. It's kind of the Swiss Army knife of features, I think. SQL views, I think they really closed the loop on external access for 4D. We had table control, now we have row control, column control, and we get this level of convenience that's quite nice also. And then full-time mirroring is really all about 4D being an enterprise solution, and for you to be able to say, yes, it has mirroring, and we can do multiple mirrors and things like that. So, thank you very much. That's the end of the presentation portion of the webinar. We're going to take a few minutes here to look over the questions.
Thank you, Josh. At this time, we would like to make a few announcements. The US 4D Summit 2014 will be at the Marriott Riverwalk in San Antonio, Texas, October 28th and 29th. We will also be offering a pre-class on October 27th and a post-class on October 30th. This year is a special year for 4D as it is our 30th anniversary, and we have planned a spectacular event on the evening of October 29th to celebrate. So please save the date.
Oh, that's going to be fun. This is the first in a series of webinars focused on v14. Josh will be returning in precisely 2 weeks to continue with this introduction with the second part. We will again be doing it on Thursday at the same time. That'll be February 6th at 9:30 a.m. I'm going to leave these slides, or this note up during the Q&A. First is the link that Josh mentioned about the new journaling system. Also, we want to make sure that we want to make the most out of our time with you joining us for these webinars. Please let us know what you like and what we can do more to improve these by returning our webinar survey. If you have any questions after this webinar closes, you may email webinar@4d.com. We will include it in the next webinar. Okay, Josh.
Thanks, Brian. Thanks, Aaron. And just if anybody had to, miss part of that or had bad audio or anything like that, we are recording this, and so we'll post it online so you can re-watch it, or if you have colleagues that want to watch it or whatever, keep an eye out for that also. So we're going to go ahead and start going through the questions here. Somebody said they were looking forward to the webinar. That's good. So one of the questions was, do the saved queries that you see in the new query editor work, client server? There's a couple different ways that I could think about answering that, but I think the basic question is, can a client use the new query editor dialog and save and load queries? Yes, of course they can do that. If you're trying to save and load queries from the language, it's not really designed to work that way. It's just from the dialog itself. A few people asked about C-object in the context of persisting the values or persisting the data. So the first thing that I think the easiest way to clarify is to say outright that C-object is a variable type. It is not a field type. It's certainly easy to translate into text with those commands that I mentioned. So you can save C-object content in a text field very easily. You can save it in a blob field, things like that. But definitely you have to convert it back and forth and deal with it that way. It's not a field type, and I would put an asterisk on the end of that and say yet. We definitely want to make it a field type, but there's different layers of implementation that need to be added. Laurent is very keen to make sure that if we make it a field type, that it's a real field type, that it can be indexed properly, that it can be queried properly. So there's a bit more that has to go on there to really make it a field type. So for now, consider it a variable type only. Let's see, what else? Similar question about the recent queries. Are they available in the 40 language? Not at this point. You access them through the query editor. There's no programmatic access really. Let's see. So one question was, the results of the view have real field names, not the view names in the column headers. That's actually not true. The example that I used, I may have reused a field name, and I apologize if that was confusing. The field names that the end user sees are completely virtual when you're using 40's views. They will not know the table name. They will not know the field names from your database. You don't have to worry about that. That was the same. How do you create views in a compiled running app? The
same way?
Yeah, same way. It's just SQL. You do begin SQL, end SQL. You can use execute immediate to run SQL code, like ad hoc SQL code if you want. Although, on the other hand, I wouldn't recommend opening up ad hoc SQL queries in a compiled app. But you could certainly build an interface to allow, like, an administrator to build SQL views on the fly and things like that.
But the one good thing about SQL View is that the creation part.
You know what, guys? One second.
Sorry.
I forgot to say that Ad is joining us. Ad Kamoncharinsari, who is our Director of Technical Services, is joining us to answer questions also. So go ahead, Ad.
Okay.
Sorry about that.
Just to point out one thing about SQL View is that the creation part or the accessing part, whether you're running in interpreted or compiled, they're all the same. And because everything happens in a runtime, so virtually when you test new code in interpreted and run it in compile, it's basically the same.
A similar question, do the views persist between sessions? They persist in your methods. So as long as you call the same methods at startup, that's how you create them. You run the code. That's all there is to it.
Right.
There was one, just a comment that in v13, when you relaunch the mirror, it will not have a log file attached. And that's definitely the point of the presentation that I did, just to make sure that's clear. One of the primary improvements in v14 is that the mirror has its own log file, its own journal file. So whether or not it's integrating changes, it's always protected by its own journal file, and that's a really important change in v14. Can you mirror to more than one machine? Very good question. Absolutely, yes. That's actually true in the v13 version as well. It's just that the way you do it is a bit different in v14. Because you can daisy chain in v14, you can have a mirror mirroring another mirror. It gives an opportunity to structure it a little bit differently. the v13 style, you can do kind of a star arrangement where you have a central production server. You could have more than one mirror hanging off that production server. You can still continue to do both of those arrangements in v14. You can do either one. There was a question about mirroring and licensing. My suggestion, so there's no straight answer to say what licenses do you need. It depends on the situation. The best way to address questions about mirror licensing is to contact your sales rep. They can work with you to figure out what it is that you need. The basic principle is you need to have more than one server license, of course, but you don't have to. The cost is not necessarily twice the amount of servers or anything like that. So definitely check with your sales rep for clarification on those. Okay. Really good question about mirroring. Do you still have to write your own code as far as for managing the log segments, for shipping them back and forth and for integrating them? Yes, that's definitely true. What we've given you in v14 is a better architecture to start from, but you definitely have to customize it to match your situation, to depending on where the machines are and things like that. Yeah, okay. Good question about what we call the selective journaling. In converting to v14, are they defaulted to on or defaulted to off? It's a slightly complicated answer. Because v14 requires primary keys in order to do journaling, if you don't have primary keys defined for a table, then the journaling of that table will default to off. If you do have primary keys defined, and you can define those today, you don't have to wait for v14, you can do it in v13. If you do have primary keys defined, then it will default to on. So hopefully that makes sense. We're just scrolling through the other questions here. Someone mentioned they seem to remember the previous mirroring used SQL. That's not true. So the mirroring based on journal files has been in 4D since v11, 40 v11 SQL.
I think that might have been referred to as synchronization
Yeah.
option.
There's the SQL feature set has a different set of commands, one called replicate and one called synchronize, which allowed you to synchronize the changes between a collection of fields, basically, between tables, but you could even do it at the field level. But that's really a different feature. That's not about what we call logical mirroring, which is I want to have a fully up-to-date backup of my production database with exactly the same data changes. That's what the logical mirroring is for. The SQL mirroring was about copying data between systems, not necessarily for backup, but just to share a data set between different systems. So it's kind of for a different, possibly a different use case. Let's see. Is there something written about the relationship between 4D and Wakanda? I believe we published Laurent Hinault's presentation from the summit, right? Yeah. Sorry, I'm asking a question to add. The presentation that he gave in Boston. Okay, I'm pretty sure. I think it's on KB. So let me state up front. So Laurent Hinault, who is our VP of R&D, gave a presentation at the summit in Boston a couple of years ago about what's common between 4D and Wakanda and what's separate and what we're working on, and kind of a roadmap of how we architect things back in Clichy in France. I believe that presentation was published in KB, so check kb.40.com to see if it's there. There's nothing that I can think of that's like documentation about it or anything like that. The general point is that the database engine in 4D is the same database engine that's in Wakanda. The difference is on the 4D side of things, you have the 4D language and the SQL language that both use the database engine, and on the Wakanda side of things, you have JavaScript that uses the same database engine. So it's the programming language layers that are different between the three of them. Are SQL views accessible via the structure editor user mode? Very good question. And I should have clarified that. SQL views are only SQL. So a different way to answer that question is you can't access SQL constructs from the structure editor or from user mode, like the virtual tables and things like that. So definitely views are only accessible via SQL. It doesn't stop you from building interface, of course, because you can fetch the results of a SQL query into arrays. You can fetch the results into a list box. There's lots of ways that you can display SQL content, SQL query content.
So as you know, the SQL data access is going to be done via variables. So everything that you pull from the database via SQL either goes into one level variable or the array type of variable. So yes, you can probably use list box and display your data that way.
Someone asked, are views inter-process? Very good question. Views are actually cross-session.
It's global.
Yeah, it's global. In a client, so in a single user context, you could think of it as inter-process. In a client-server context, it's actually global to everyone. It's available to the server, available to all the clients. Images and objects, good question. A lot of people were asking, how come you don't support images? We do support images. The thing about C-object is underneath it's JSON. It's text, period. That's the only thing JSON, the JSON specification specifically restricts it to text. The way you store images in JSON is you encode it.
Encode it into base 64. That's probably the easiest way to do. So once you have that, you can stick it into either a text field or a blob field. That's quite simple to do.
Yeah.
And you can, one thing to point out, looking at the C object feature is for me, is there to allow you to have a better manipulation and access to the JSON structure. It's quite simple to use everything through the language rather than dealing at the text level.
Okay, several questions here about mirroring, which is good. I'd like to clarify these. Can 40 server mirror to 40 standalone? The easy way to answer that, I think, is the integrate log file command requires a 40 server product. So the mirror must be a server. I think that's
right.
Easy enough. Yeah. Can you mirror a compiled merged application? Absolutely. The way it's deployed, whether it's interpreted, whether it's compiled, whether it's merged, doesn't matter. They all have the ability to do mirroring. Someone mentioned if they have two mirrors and they do a backup on the mirror, it'll break the mirror. That's really part of the point of the presentation that I gave comparing v13 to v14. The idea with v14 and the fact that a mirror has its own journal file, you don't have to do that backup dance where, anyway, if you've been through it, you already know what it's like. If you haven't been through it, don't worry about it because it's much easier in v14. Okay, so we are at at 1 hour exactly. There's just a few questions left. We will go ahead and go through them offline. I believe we're going to publish the questions and answers, right? Yeah, so they're going to, the marketing group will publish all the questions and answers from today. We'll be sure to type up our replies so you guys have copies. That's it for me. Well, thank you guys. Let you guys take over, you marketing folks.
Thank you for joining us today, and we'll see you guys in 2 weeks.